Hello guys, welcome back. Today I'm going to start today questions, right? So this is the Leetcode question 703, the kth largest element in the stream, and we are going to see the implementation. Okay, so let's read the question first. So question is saying that design a class and we have to find the kth largest element in the stream, and we have to find what we have to also see that it is a kth largest element in the sorted order. Okay, so we have to find the kth largest element in stream, and it is a kth largest element in the sorted order, not the kth distinct element, right? So we have to also check, we have to also implement the kth largest class, in which we have two methods, right? One is kth largest element and another is you can say add method, right? We have to find these two, we have to create we have to implement these two methods to get this kth largest element from the stream. Okay, so let's understand how, what is the meaning is this, right? So we, first of all, what we have to do, we have to implement this one, and then we have to add all the values. And once this is done, so we have to find the kth largest, means you can see here, right? So we have to find the kth largest, right? So as you can see, we have the kth largest element are, these are the element that we have, so we have to return like this. Okay, so first of all, in the explanation, as you can see, first we have created an object of this class, right? So this object will have another method, right, in the class. So he will call the method add, like 3. So it will return first of all what we have initially, we have 3, then we have 4, 5, 8, 2. So what we have to do, after adding 3, it should return what it's 4, right? What? So this, see, the question is saying that when we are going to add int, right, here you can say append the integer val to the stream and return the element representing the kth largest element in the string, right? So if you see the kth largest element, what we have here is 3 we have, right, as you can see. So when we are going to add 3, it will return 4. When we are returning largest element 5, right, here we are adding, means it will append the value to the stream, and so it will return now 5. Then we are going to add 10, so it will return 5 again, right? Like this it will return 8 and 4 9 and 4 8 and 8, sorry. Like this it will return. So how it will work, that we will see, but first of all you have to understand this one, right? So first of all, what we should do here, we will pop the element from the largest element until it will return k equal to 3, right? Then whatever index we have, that we have to return. Okay, so when we pop the element, let's suppose from here, means now we have to find the smallest element, right? So which element is the smallest, right? So we'll have to find. Now we are going to do what, we are adding some element. Let's suppose we are adding into 3. So then what will happen, it will pop from the smallest element and it will return the 4 element, right? That we can see. Okay, give me 1 second. Okay, so what I'm trying to say here, let's suppose initially you have did we change the color? Initially you have some element, like we have 2, 4, 8 and 5. This is the array you have, let's suppose. Okay, now what we have to think, if this is your array, okay, and we have given k equal to 3, just for understanding. So now it means what, we will initialize a heap using this array, and then what we will do, we'll pop the smallest element until what we have, the length is equal to k equal to 3, means this one, right? So it means what I'm trying to say here, first of all we will initialize the heap and then we will check the length. If length is equal to, then we will do this one, right? So if length is equal to this, then we'll do what, we will say now we are going to pop, right? So when the length is coming to 2, right, the element, smallest element, we have to pop at that time, right? So which one is the smallest element? So length is equal, right? Length is equal, so what we are going to do, the smallest element we will remove from here, right? Now what will be the remaining element? 4, 8, 5, like this will be the remaining array will have, right? Now what we will what is the smallest element was that 2 was there, so we have removed that one, right? Now let's suppose we are going to add 3. Just for understanding, we are going to add 3, right? So when we are going to add 3, then what will happen? We will push this into this array. Let's for understanding. Okay, so now what will happen? The element that we have pushed, right, immediately is it smallest, right? So if this is the smallest, so we will return a smallest element first. So what is the smallest element here? 4 is the smallest element from here, right? So all numbers up to this point in the sorting order, what will happen? First initially had smallest was 2. Now we have 3. Now we have 4. Now we have 5, and then 8. Like this, we will create our array. Okay, so this will be your you can say array which is in the sorted order, right? Let's suppose now I am going to add 5, right? Like this we have done, right? So we are going to add 5. So what will happen? We will push the 5 into the this memory, heap memory, right? Okay, so what will happen? Heap is this one. This is your heap, right? And this is your array, right? So what will happen? We will pop the smallest element, right? Which is what we have. The smallest is 4, right? And then the heap is maintaining the kth largest element in the stream. So it will return the smallest element, which is have. Now if we will remove from here, now it is 5, right? So all the numbers till that, what will happen? It will look like this one. Just we have to update this one. So we are going to add this 5, right? So it will become 2, 3, 4, 5, 5, 8, right? This will be your array like this. Okay, so now you have all your sorted value, just for understanding. Now think, if we are going to add now 10, first we have added 3, now 5, and then we are going to add 10. So when we are going to 10 into this heap, right? Okay, so now what will happen? Now heap have 5, 8 and 10. 5, 8 and 10 into the heap. This is your heap. Okay, so we have just added 10 here into this heap, right? So now you have this heap like this. Then the pop element, we have to pop the smallest element from the given stack. So this is the top element on the stack. So what will happen? This is your smallest element, so we have removed this smallest element, right? Now what is this what is the remaining one? It is 8 and 10. Okay, 8 and 10. Then till now, what is the smallest element, right? We have removed what? 5 we have removed. Now your array will look like here. Let's suppose 2, 3, then we will 4, 5, 5, 8 and 10. This will be your final array like this. Okay, so this array is sorted, and as you can see here. Now suppose we are going to add one more element, just for understanding 9. So what will happen? This array, this is your heap was there, right? So now your heap will look like 8, 9 and 10. Okay, after removing, right? 8, 9, 10, because added 9, right? So previous was what we have added, we remaining was 8 and 10. We have already removed the 5. Now it will go 8, 9, 10. Now what will happen? We are going to add 9. So we have pushed into the heap. Now we will find the smallest one, that is this one, and we will pop the 8, right? Now what we should do? We will remove this from a stack, right? And what will happen? We have to return the smallest element, that is 8, right? So what will happen? The new array will be look like 2, 3, 4, 5, 5, 8, 9, 10. Correct? So this will be your answer, as you can see. So it will look like this. Okay, so actually what we are doing, first of all, as you can see here, right, in this one, right, first of all we are doing what? In the constructor we will create a minimum heap using the element from the given numbers. So if this is a given numbers, right, let's suppose, just for understanding, if this is a given number, right, so we will get the element from the array, and then we will create our minimum heap. Okay, and then we will pop the heap until we have heap dot length, right, that we are saying, right? If it is equal to, then overall what we will do, for every calls we will add a new element and we'll first push into the heap. As you can see, each time we are adding, right? So we'll add into the heap, and then we'll check if heap length is greater than k, then what we will do, we'll return the minimum element, and we'll pop from element heap. Okay, so that element now will return as a smallest element from the heap, and it will give you your array, as you can see here, like this. You have the all elements. So finally what will happen, you will get your smallest element, and you will make your maintain your number, right? So let's understand how to implement this one. Let's go to the browser. So I am here at the browser. Now we are going to implement this one. So as I told you, right, first of all we will create the priority queue, right? So we will create a heap memory, and to do that, what we have to do, better we will create from here only. Okay, yeah, as an instance, right? So I'll take let's suppose I'll take a private, right, and then I will say we will pass a static, and that is nothing but int k, and another will take int k, and then what will happen, we'll take private, then we'll take a priority queue, and then we will take two things, right? First we'll add integer, and then we'll give the name, that is nothing but our heap memory. This is your heap. Okay, two things we'll have. Now what we should do, we have our heap and we have our k, right? Now you have the element, right, from the array. So from here we have our element. So from element we'll create our heap, will initialize our heap. So this dot k is nothing but your k, correct? Now heap is equal to, we will initialize the heap into here, priority queue, like this, and we'll say like this. Okay, now from each element of the nums, right, we will get our int n element, like this, and then what we will do, from each element we'll push onto heap. Now we are going to offer or push or add. So I'll going to add we have element, right? Okay, now each element will store. Now once our element are added onto the heap, we will check, right, while heap dot size, if heap size is greater than equal to, you also say greater than k, then that time what we should do, heap dot poll we will do, and we'll remove from the heap, right, and we'll get our smallest element right here. Now once this is done, we will have to add each element at a time, right? And to add the element, what we have to do, we have the value, so we'll check on the heap dot offer, and we'll add val, this one, and then similarly we'll check if condition, if heap is having the size greater than what, k. So here we'll do heap dot poll, right, and then we will return the minimum element, and that will be on your peak, from the top of the stack we'll remove, right? So this is what we have to implement, right? Let me run this one, let me submit. Yeah, this will work, right? Now think about the time complexity and space complexity. Okay, sorry. So when we are going to implement this one, as you can see, we are going with all its number, right? And all its number we are storing onto the heap, right, and the priority queue, right, as you can see here. So the space complexity will come what, O of n, because all the element will store on where, space complexity equal to O of n, right? So this will be your space complexity. Okay, now if you'll talk about the time complexity, so we are going with all the elements, right, but we are using the heap, right? So it will do the sorting also, right? So here time will to heapify, as you know, right, that part it will take O of n times. That we are turning all the element into the heap. That will take O of n times, because we have n elements into the array. Okay, and when we are going to remove from the heap, it will only take what, k times, right? So what will happen, we have to remove n minus k elements at a time. So since k is nothing but we can say if this is 1, right, so this will come, it will come O of n, O of big O we can say, right, n operation for the n operations, right? So it will call log of n, right? And to do that, what we have to do finally, we can say, sorry, time complexity will come for n element will get log n, right? And this will be your O of n. Okay, so thank you for watching this video. If you like this video, please hit subscribe this channel. So okay, sorry, one more thing, to this activity, it will also it will do the what, constructor will take the time, and it will take one more thing, plus you can say O of n, right? That I forget. Okay, so thank you guys, thank you for watching this video. If you like this video, please subscribe this channel. Thank you for watching this video.